our goal is to answer this question. How is the conservation of matter represented in balanced chemical equations? That's our goal today. Our goal is to take word problems, put them into formula problems. That's what we're focusing on. And we're going to get a little bit into actually balancing out those formula problems. So now we get into the things that we're going to need for the day. One thing you're going to need for today is you're going to need a partner. You're going to need to come over here. You're going to need to grab a couple things. You need to come over here and grab word problem, word equation, skeleton equation sheet. This is our classwork today. You're going to grab the balancing equation worksheet. This is your homework for tonight. You and your partner only need one stick of chalk and grab 10 flashcards from my bag. You and your partner only need 10 of these cards, one chalk, one piece of paper per person. So, find a partner, come get your stuff, and you want to clear off your desk area a little bit. We're going to be writing on the black tables. This is where we all get up, guys. You can do it. I promise. There we go. I thought I lost myself. Hold up. Sir. Yes, test grades are in. As of right now, everything is graded. That's going on the third quarter grade. What it is right now is what's going to appear on your report card. I do apologize about that. That was on my GIF slide that was up there earlier. Key thing with that one, guys. So if you're missing something from Unit 6, you have to the 26. That's next Thursday to get it into me to get it graded. The sooner you get it in, the easier it is on myself. That's why I'm giving you the full 2 weeks. Excuse me. But if you have, what I'm not going to take is anything from Unit 4 or Unit 5. The only thing that's available right now is stuff that you did not turn in from Unit 6. So I kind of just wrap everything up at the end. Ma'am. So you are third person in line because I got Lindy out, I got Allison going next, and I got you. Sound good? All right. Oh. Dropping pins. So what does that mean? That means if you got 69% or lower, your parents are going to expect an email from me saying, hey, we didn't do so hot on the third quarter. Ladies and gentlemen, if you have not been doing so hot for the first, the second, or the third quarter, and you're hoping to lock in, power through this last one, you got some work ahead of you. There are 3 units that we have to get through this quarter. And that's also adding SOLs, because next week, my juniors, you guys are going for your writing SOL, right? The 25th, 26th, 27th, I think the days are for it. There's several days for it, I know. It's Tuesday and Wednesday. It's Tuesday and Wednesday. I apologize. So you got that. Then we go to spring break. We have a couple days off in April, and then we reach the absolute maelstrom that's going to be May. Now, I have a couple seniors in here. Now, seniors, you know that you guys are wrapping things up earlier because the goal is that to get you guys walking across that stage on the 27th of May, if I remember correctly. Is that our day for graduation? I'm pretty sure it's the last Thursday. 28th, I take it back. 28th of May, last Thursday of May. And I'm pretty sure it's like super early in the morning too. Like they were not kind to y'all. They could not pick the worst time. I guess I think it starts at 9 in the morning. But it's like we're there for 2 hours, so we have to clear out for an hour, and then some other high schools then come in behind us. There's a schedule, and there's always something. But the goal is that for my seniors, you have more than a foot out the door. You're almost there. If you need this class in order to get your standard diploma, let's make sure we're doing what we need to do. If you're in this class to get your advanced diploma, which most of us are here for, know that you need to pass this class in order to get it. So if you're rolling into quarter 4 with an overall 54% as a grade, you got a lot of work ahead of you. I'm not saying it can't be done. Quite the opposite. But this means that you got some work to put in. That's all that means. All right. So everyone's got a partner, yes? Who doesn't have a partner? All right, so Angie, Sadia, congratulations, your partner. Jen, Mason, congratulations, your partners. Fix that real easy. Lindy. One second. Allison, who's your partner? Person. All right, I'm gonna put you. So Glindy, Jen, Mason. So make sure you get all the tools that you need. You guys 3 are gonna working together. Oh, I need a copy of the word problem myself. Give me a quick second. So what I want to do is I want to look at the word problems, the skeleton problems paper first. That's the paper we're going to start looking at first. What we're going to do is we're going to go over some vocabulary that I know you've seen before, because everybody in this room was in 8th grade middle school at some point before you came here. Now, I do understand that those who have spent a lot of time since 8th grade middle school, this may be a little bit more heavy lifting for you than some of my sophomores are. But I promise you, you're going to see this come up again. And these words we're going to be using a lot of. First thing we're going to take a look at is the term skeleton equation. An equation that shows the formulas for the reactants and products of a chemical reaction or change, written on the proper side of the arrow. And here's my example: lithium plus calcium hydroxide yields or will form calcium metal plus lithium hydroxide. Now the key terms we want to look at is that the items on the left-hand side of my arrow are my reactants. What are reactants? Well, right underneath here, the reactants are the chemicals that you have to start the reaction with. So they are stuff we're going to start off with. And where do I find them in my formula? I find them on the left-hand side of my arrow and equation. Whatever's on the left is what I start with. Those are my reactants. They are always found on the left-hand side of my formula. The right-hand side, the calcium and lithium hydroxide, are known as my products. These are what's being produced. The chemicals that form produced from said change. And where do I find the products? There is on the right-hand side of my arrow. In general chemistry in high school, we're mostly going to focus on one-way equations. If you elect to take chemistry in college, you may see some arrows that look more like this, meaning that the reaction can go both ways. until it reaches a status that we know as homeostasis. But everything that we're going to do, we're going to use this type of arrow here, an arrow just pointing off to the right. That's what we're going to focus on. Now, these terms, like I said, should be familiar to you. The further you are away from 8th grade science determines how quickly you're going to remember my reactants on my left-hand side, what I start with, and my products on my left-hand side, what I produce or what I form. But, a little bit of review. Now, let's talk about what you guys are going to be doing. Why did I give you guys cards? Why did I give you guys, excuse me. Why did I give you guys cards? Why did I guys put you in partners? Because you guys are going to be working together to write out the compounds. I forgot to get this up in this front again. So, you guys are going to build these word problems that are on the page in front of you. Excuse me. Using our index cards. We're going to lay our index cards out in front of us. One person is going to be in charge of the reactants. One person is going to be in charge of the products. So my example here, that's not on your piece of paper, is sodium phosphate plus calcium nitrate yields or will form sodium nitrate and calcium phosphate. Now, to make this easier, one person is going to be in charge of writing the formulas for the reactants. The other person is going to be in charge of writing the formulas for the products. You guys need to make sure that you are writing your plus signs in between your reactants and your products, and the arrow to indicate will form. So this will form. That's what we're doing. I'll give you a quick second. So, I make this a little bit easier for us. So, let's say that Mr. Wiseman is on reactants and products. So I have my two cards, right? Two cards from my reactant side. Sodium phosphate. So my person that's doing sodium phosphate. Let's see. Sodium, if I'm looking at my periodic table, that's Na. What's the charge on sodium? +1, +2, +3. What's sodium? Look at your periodic tables, ladies and gentlemen. You have them in front of you. +1. There we go. Phosphate, is that PO3 or PO4? 4 with a -3 charge. So, do my charges cancel each other out? No. What do I need to add more of? I need some more sodium, right? Na3, I need 3 of them. PO4. So, there is my sodium phosphate. Now I need to figure out calcium nitrate. Calcium, that's Ca plus what? 1, 2, 3, or 4? What's calcium form? 2. Nitrate, NO, 2 or 3? ATE, 2 or 3? 3. With a -1 charge. My charges don't cancel each other out. Ca parentheses NO3 close parentheses 2. So that's my plus. You're going to write on your black table, you're going to use your chalk to write your plus in between your two reactants. And your yield arrow. Sodium nitrate. Sodium nitrate, I saw that was Na +1. NO3 -1, so they're going to cancel their charges out. Sodium nitrate plus calcium phosphate, Ca +2, PO4 -3, which gives me Ca3 parentheses PO4 close parentheses 2. This is what you're going to write on your table for each one. You want to separate your reactants by your pluses. You're going to separate your products by your pluses. And there's going to be an arrow to tell me from my reactants to my products. Let's look at the first one together. Did I grab an extra copy? I did. Perfect. So I don't think I have it on this page. I don't. So slide it over. All right. So looking at number one together. When I see zinc by itself, what's the chemical formula for zinc? What's it say on your periodic table? What's it say, gang? It's a transition metal. Zn. Now, I have lead 2 nitrate. Now, question. I have lead. Lead's one of those weird ones where I have to indicate the charge. What's the charge on my lead here for lead 2 nitrate? +2. Pb +2. I know nitrate's NO3 from what we just did before. So we need Pb parentheses NO3 2. So I have my 2 reactants. React to form, that's just my arrow. Zinc nitrate. Now, what charge does zinc give me? Do I have to specify the charge, or does it always have a specific charge? No, I don't. I'm not lying. There's no cap here, ladies and gentlemen, because remember, when it comes to my transition metals, there's 3 metals that are weird. There's aluminum that always forms a +3. Zinc is going to always produce 1 charge, and silver always gives me a +1. What do we think the charge is for zinc?
4.
Not 4. 2. Zinc will always give me a +2. Aluminum will always give me a +3. Silver will always give me a +1. So because of that, remember your rules, guys, because they're not going away. Because zinc is a +2, it's ZnNO3 2 plus lead. What's my symbol for lead? Pb. There's my skeleton equation. One thing I do want to remind you guys of, because I look at question number 2, I assume I look at chlorine gas and bromine gas. Now, normally when I'm dealing with a gas, I'm dealing with just that compound. But we have to remember, we have several diatomic elements. These mean I do not find them by themselves. Never by themselves. You might want to write this down if you don't remember. There are 7 of them. Anybody remember one of them? All the way back from Unit 1? Unit 2 at this point. Give you a hint. They're orange on a periodic table. Do you have to tell me what they are?
I can't see it for a way. There's something.
What are the 7 elements that are diatomic? Nitrogen's 1. Oxygen's 1. Fluorine, chlorine, bromine. What's the other one? Iodine. We're missing 1. Hydrogen. Meaning that when I find these elements out in the wild, hydrogen I always find as H2. Nitrogen gas, N2. Oxygen gas, O2. Fluorine gas, F2. Chlorine gas, I keep wanting to say glass, Cl2. Bromine gas, Br2. Iodine gas, I2. I never find them by themselves. These are super electronegative elements. When I find, like oxygen by itself, it's known as what's considered a free radical. It does terrible things to biological systems, such as us. It rips apart, cell membranes. It's one of the reasons why hydrogen peroxide is such a great antiseptic medication. The only problem is that it's not particular at which cell membranes it rips apart. It rips apart the bad cell membranes of the bacteria, but also tears apart your cell membranes. Why? Because it forms that free radical oxygen, and that does terrible things to biological systems. I want you and your partner figure out who wants to do reactants, who wants to do products. I want you guys to do questions 2, 3, and 4 on your sheet. I'm going to come around and check it to see where you're at with it.
So we don't need anything.
You need the white cards, you need your chalk, because you're going to put it all, you're going to write it on your table. So in order to do this, you need to clear some space out, because you're going to write it on your table. I got to see it on the table. Now you can use the restroom. What? We're working with the partners, ladies and gentlemen. Someone's doing reactants. Someone's doing products. Emily's next. All right, so you're using the cards here to write your I think I'll put the plus in the arrow side. So you get the remove line on one card. I did chlorine gas would be another card, so get plus arrow. Because you got remove chlorine on one card. Work together on it, guys, because
So 8L plus 1.
aluminum, it doesn't give me a +1 charge. Which charge does it give me?
2.
Doesn't give me a 2 either. Gives me a 3. Be mindful of your charges, ladies and gentlemen. When you get question 2 done, raise your hand, show me. Non-metals are always minus because they are more electronegative. So the rule of thumb is whenever I see a metal, it's a +1. Whenever I see a non-metal, it's a -1. When I see the metalloids, those weird semi-metals, they can go either way. Well, who's doing reactants? That's my first question. Who's writing the reactants? Who's writing the product? All right. So you're doing reactants. So you're going to use this sheet right here. So you're in charge of writing point for aluminum bromide and chlorine gas. Now you can cheat because chlorine gas is right there on the board. What? You have one card for aluminum bromide, so you can write the formula for it, and one card for chlorine gas, which is CO2. And you got what? Now, you, sir, you are doing the reactants. You are doing. Nope, you're reading the formula. Because I already have it written down, you're doing the formula. You are doing the formula of aluminum chloride and bromine gas. Which is good for you, because bromine gas is also right there on the board. Yeah, BR2. So, very different. But you did well. But you got that one. That works too. Here's the problem. Aluminum bromide, aluminum, what's the first name? Aluminum bromide. So, well, they do question 3 and 4. So you're giving me the formula for aluminum bromide first. That's not the, you're saying that for every aluminum bromide, I only need 1 of bromine. All right, and the chlorine gas is 2, right? Chlorine gas, so chlorine, not by itself, always plus 2. Or not plus 2, it's always Cl2 for 2 atoms. Now, so you did reactants, Zaire's going to write the product. So he's going to figure out, like the formula for aluminum chloride and bromine gas. Now, good news for him, bromine gas is already up on the board right there. Part of it. How do you guys work it out?
Yes, because
Think about it. I'll tell you right now, it's wrong.
Okay, this, I feel this is wrong.
Because it's bromide, so it's connected to the binary compound.
Well.
Ladies and gentlemen,
Okay.
do you remember? Hey guys, do you remember when you see the word I-D-E, at the end of one of your elements? That means you're looking at a compound. So you need to give me the compound's formula. Don't give me the name of the compound. I already have the name written down for it. I want the formula of said compound. Don't give up because this is just the start of Unit 7. We haven't even got to the fun stuff yet. By the end, when we come back from spring break, you'll be able to tell me the difference between the 6 different types of reactions that we are going to be using. Jason, just sitting in your head down. No, jump in there. Don't let Jen do all the work, man. Let's see what it is. Nice. So that is our skeleton for number 2, right? So we'll write that down. We should try number 3, right?
So then if there's an item to compound, so then it's what? We are ready? We write it here first.
Perfect. Yeah, I see what you're doing. All right, very good. Good stuff.
And
Yes.
30. Exactly.
The bromine then changed to, remember, I thought it became aluminum chloride, so why did you write aluminum bromide? ALPL. Now you gotta tell me what the charge is. Not charging, but how many meters extra? Okay. All right, ladies and gentlemen, I've hit mine. 3 people have figured out my 3 groups have answered questions 2 and 3. So we're gonna keep moving forward. Let's look at question 2 together because I saw a lot of people struggle on 2. Ladies and gentlemen, I know it's been a unit in between when we were naming our compounds and today. I gave you guys a excuse me, a cheat sheet in naming our compounds. How to name our ionic compounds, our covalent compounds, and our acids. I gave you a graphic for that. I'm going to be printing some copies of that said graphic and handing them out to you next time, because you need to know how to name, write the formula out of your compounds for the rest of the year. If you only picked it up for that Unit 4 test, I got bad news for you. You need to go back and pick it back up, because we don't leave nothing behind when it comes to chemistry. Everything keeps building on top of itself. Knowing what our charges are. That was in Unit 2. Our polyatomic ions are going to stick with us all the way to you leave me, seniors, at the end of May. Underclassmen, the first week of June. If you have not picked up and put those 16 polyatomic ions in your head, you better start. Because here is where stuff starts to get hard. It has not. It gets harder. The reason why we need to balance our equations is because we get the stoichiometry. I want to say, hey, you have X amount of sodium phosphate. How much sodium chloride do you produce? We are jumping between moles of reactants, moles and grams of reactants, and moles and grams of our products. Being able to jump back and forth. That's Unit 8. That's not even the end of the year. If you are not picking this stuff up, you need to do the work. Because it's your grade. That's even before we get to ideal gas solids. PV equals nRT, and then we start memorizing what those words are and the different constants that are in it. Looking at number 2 together. Aluminum bromide, the IDE. Guys, tells me that's a compound. I have aluminum, I have bromine. Aluminum, I know, has a +3 charge. Bromine, I know, has a -1 charge. My charges have to cancel each other out. AlBr3. I gave you chlorine gas from the beginning. Cl2. If it's by itself, my 7 diatomic elements are never by themselves. They're always found with another copy of that same element. Hydrogen in the real world is not found as just H. Hydrogen gas is always H2. Nitrogen gas makes up 78% of our atmosphere, N2. Oxygen makes up another 10% of our atmosphere, O2. Fluorine, found all over the place. When it's in gas form or by itself, it's always F2. Chlorine gas, or chlorine just by itself, was always found Cl2. Bromine gas, always found as Br2. Iodine gas, always found as I2. Remember your diatomic elements. That was Unit 2. React to form. That's my arrow. Aluminum chloride. Al+3. What's my charge on a chlorine? Not 2. -1. AlCl3 plus bromine gas, Br2. This is our wake-up call. If you've not forgotten it, you need to find it again. I'm going to give you another copy of the same graphic organizer I gave you at the end of Unit 4. You probably have it floating around in your folder. or your notebook, or compressed to the bottom of the black void known as your backpack. You'll get a brand new copy next time, but you need to make sure you have that with you. Now, why do I worry about stuff like this? Because we're getting into balancing these equations. So looking at question number 1, our goal is to balance, make sure I have the same amount of atoms on one side of my reaction as I do on the other side of my reaction. Before we get too far in, I want to actually count. One second here. I want us to count out our elements here. Question. If my orange circle means zinc, how many zinc atoms do I have in my reactant side? How many do you see? 2? See 1, right? 1. If my red triangle means lead, how many lead atoms do I see on my reactant side? 1. If my green diamond represents nitrogen, how many nitrogen atoms do we see? 2. If my purple lightning bolt represents oxygen, how many oxygen atoms do we see? 6. What I did was I wrote that down. For the different types of atoms I have in my reaction, I wrote them down. Zinc, lead, nitrogen, oxygen. Now here's the thing, is that my product, I can only have the atoms zinc, lead, nitrogen, oxygen. The law of conservation of mass says I cannot create nor destroy atoms. Unit 3. Therefore, I cannot just make an oxygen become a lead atom. I cannot make a nitrogen become a zinc atom. Whatever I start with on one side, I have to see on the other side as well. So we counted our reactants. Let's count our products. If the orange circle represents zinc on the product side, how many zinc atoms do I find? 1. Right here, right? I have 1 zinc atom. If lead is represented by a red triangle, how many lead atoms do I have in my product side? Red triangle, you have none?
Oh,
1. Right here. If purple diamonds represent nitrogen, how many nitrogens do I have in my product side? I said, sorry, green diamonds. 2. If purple lightning bolts represent oxygens, how many oxygens do I have in my product side? 6. I started with 1 zinc, I ended with 1 zinc. I started with 1 lead, I ended with 1 lead. I started with 2 nitrogen, I ended with 2 nitrogen. I started with 6 oxygens, I ended with 6 oxygens. Everything adds up. I have to add nothing to my reaction here. My skeleton equation matches my balanced equation. So here, skeleton matches balanced equation. Let's see when it doesn't. Looking at number 2, I'm going to rewrite the formula for number 2 that we came up with. AlBr3 plus, actually I'm going to write this with the thicker marker, Cl2 yields AlCl3 plus Br2. Now, Just eyeballing this, I know that this equation is not balanced. I can see I have 3 bromine atoms over here, and I have 2 bromine atoms over here. Something is amiss. And also, somehow I added a chlorine atom. Did one of my bromines break down and become chlorine in my reaction? Did I break the first law of chemistry? No. What this tells me is that this equation is not balanced. So I'm going to do the exact same thing as I did before. I'm going to count out Al, Br, Cl. Now, to be fair, this is going to be a lot better if I had pencils to do this with, because we're going to be doing a little bit of erasing. Now, it doesn't matter which atom I start off with. I have to check all of them. Which atom do we want to balance first? Aluminum, bromine, or chlorine? I got a request for bromine. We'll do bromine. So right now I have 3 bromines on my reactant side. I have 2 bromines on my product side. What is a number I could use that's a multiplier of both 3 and 2 that I can have the same number on both sides? If I wanted to equal each other and I want to be able to multiply this number to get that number, what number can I use? What's a number that 3 and 2 share with each other? 6. 6, right? How do I get 6 bromines on this side? I use a coefficient of 3. 3 times 2 equals 6. Over here, I need 2, 3, 2 times 2 times 3 now gives me 6. Are my bromines balanced? Let's do chlorine next, because this next one down. I have 2 chlorines on one side, I have 3 chlorines on the other. I can do the exact same thing, right? I use a coefficient. So if I put a 3 here, 3 times 2 equals 6. How do I get 6 from 3? What am I going to do to the 3? Multiply by what? 2. All right, now I got to go. So once I've gotten chlorine now, I go back. I didn't change anything. I didn't change my bromine. My bromine all lined up. Now I look at my aluminum. I have 2 aluminum on one side. I have 2 aluminum on the other side. Is my equation now balanced? Whatever I started off with over my reactant side, does it now equal my product side? Absolutely. We are now balanced. That means that the balanced equation is 2 aluminum bromide plus 3 chlorine gas atoms will react to create 2 aluminum chlorides and 3 atoms of bromine gas. That is my balanced equation. That is what we're doing with the remaining time that we have. Let's look at our balancing equation worksheet. Balancing equation worksheet. Now, your homework for this evening is going to be the front page. So here, I am given oh, wait, before I get to that, pause. I forgot. I almost forgot one quick thing. We want, first of all, write this down on your previous sheet. We want to talk about the what, the why, and the how do we balance equation. What is the what? If there was a test and I asked you, what is a balanced equation? So these are talking about balanced equations. The what is a balanced equation is we want to make sure we have the same number of atoms on both sides of our equation. That's the what. What is a balanced equation? That's what we're focusing on. Our goal is to make sure that we have the same number of atoms of each element on both sides of the equation. That's why it's important for me to know the rules about writing the formulas for said equation. Yeah, you can write it on the back of your coursework paper. The why. The why is the law of conservation of mass. Atoms are not created nor destroyed within a chemical reaction. There's no chemical equation that we are going to look at here in high school chemistry where we're going to take something and make it different. You start doing that when you're looking at fusion. Smashing two atoms together in order to create something else, releasing a bunch of energy. Currently what's happening in the center of our sun. The reason for why we balance equations, we want to make sure we have the same amount of atoms of each element on both sides of the arrow. The why is because of the law of conservation of mass. When I do a chemical reaction, I just don't start making new things. How do we do this? You have heard this term before, but when you saw these numbers in the front, that's a coefficient. Same thing as a coefficient in algebra. If I have 2 outside parentheses of 1 times 3, I have to distribute that 2 to the contents of my parentheses before I can move forward, right? Same idea. That 2 means I have 2 aluminum. That 2 means I have 6 bromines. That's a term you've already picked up in algebra. Your coefficient goes in front of your parentheses. We are going to add a coefficient in front of our compounds to indicate we need multiple numbers of that compound to get this even amount of atoms on both sides. Sorry. I'll go back in a second. There you go. All right. So let's take a look at the homework together. Look at a couple of them together. Now, I want you to understand that the homework for this evening is this front page. Homework is just the front. 15 questions. We're going to do a couple of them together. Don't worry about the back. The back is just for additional questions or possible alternate assignment. If you knock out the front, you're going to be just fine. Let's look at number 1 together. I'm going to grab an extra sheet of paper to make this work a little bit better for us. You may also want to have a piece of paper out to rewrite your question. So my first question is, balancing equation worksheet, insert the coefficients in the following blank spaces to balance the equation. If the coefficient should be a 1, simply leave the space blank. So I have space N2 plus space H2 yields blank NH3. How you should attack this question. How many different types of atoms do I start off with? Different types of atoms. Different types of elements. What elements do I start off with here? 1, 2, 3, or 4? 2. What are they? Nitrogen, hydrogen. On my product side, do I end with the same 2 types of elements? Absolutely. Now, we could choose to tackle this either going from nitrogen and then hydrogen, or we can do hydrogen then nitrogen. Which one would you like to go with first? Hydrogen. Sure. Currently, I look at my product. I have 3 hydrogen atoms over here, yes? I have 2 hydrogen atoms in my reactants. I can push it to 6. So in order to get 6 on my, in order to get 6 on my product side, what coefficient should I start off with? 2. 2 times 3 equals 6. What is the coefficient I should put in front of my hydrogen to get 6 hydrogens? 3. 3 times 2 equals 6. Now, I look at nitrogen. I currently see N2, so it means I have 2 nitrogens already. 2 times 1 nitrogen is 2. Is my formula balanced? Is my equation balanced? Do I need to put anything in front of the nitrogen gas? No. Because my rule is, if the coefficient should be 1, leave it blank. So I leave it blank. So my correct answer is N2 plus 3H2 equals 2NH3. These are just the coefficients. That's all we're doing. There will be a quiz in a week from now. Being able to balance equations. You're going to have to, you're going to see it in both ways. The coursework way that we did today, where I give you the written formula. And you must take the written formula and determine the, the written equation and determine the formula equation. And there's going to be questions like this, where I give you an unbalanced equation, and you have to balance it like this, just writing the coefficients. We got a little time. I say we do maybe like another 1 or 2 of them. What do you say? Are we okay with that? Or y'all want to just do it by yourselves? See, I don't know about you guys, but I'm very auditory. I don't know what head shaking means. I don't know if you're shaking your head at me like, oh, God, here we go again. Hey, there we go. I like the responses. Let's do number 3 together. We'll jump around. NaCl plus fluorine gas yields or forms sodium fluoride. Oh, have to put a space there. And chlorine gas. So I've rewritten number 3. Naming one of the different atoms in the reactants. There's 3 of them. Naming one of the different atoms in the reactants. Potassium? That's all right. Number 3. Sodium. Na. What's another one? Chlorine. Cl. What's the other one? Fluorine. There we go. All right. Now, which one do we want to balance first? We want to balance the sodium, the chlorine, or the fluorine first? What do you think, Leslie? Which one do you want to do first? Sodium it is. Currently right now, I have 1 sodium over here, yes? I have 1 sodium over here. It's important with these multiple ones that we have is that when we balance one, we may have to go back and check the previous ones that we balanced. So we did sodium. Sodium's there's 1, there's 1. So far we're okay. What should we do next? Should we do chlorine or fluorine next? Chlorine. All right. So right now I have 2 chlorines over here on my product side. I have 1 chlorine over here. What can I do to get these to balance each other? I have a 2, and I have 2 of my products, a 1 of my reactants. What should I do? Because clearly they're not balanced right now. What can I do on my reactant side to match it up to my product side? What coefficient should I use? Was it? Use a 2, right? Well, it has 2 over here, right? So I have 2 right here. Now I have 2 times 1 equals 2. Now they're balanced with each other. But here's the thing. Now I have 2 sodium and 1 sodium over here. Then I have to go back. What can I add to my product side so it matches my reactant side? 2. So, what about my fluorine? I have 2 fluorine in my reactants. How many fluorines do I have in my product? Do I have 1, 2, 3, or 4 fluorines over on my product side?
1.
No, I don't. There's a 2. 2 times 1 equals 2.
We can do it on a separate piece of paper.
Yeah, you can do it on a separate piece of paper. That's fine. I'm not against you doing it on a separate piece of paper. Just make sure you bring in that piece of paper. Having a piece of paper, putting it underneath the yield side, the arrow, breaking it down. I have a sodium atom, I have a chlorine atom, I have a fluorine atom. Boom, boom, boom. However many sodium atoms I have on my left-hand side, my reactant side, I have to have that many sodiums on my product side. However many chlorine atoms I have on my reactant side, I have to have that many chlorines on my product side. However many fluorine atoms I have on my reactant side, I have to have that many atoms of fluorine on my product side. Ma'am.
How come you didn't put the 2 between the NA and
Because that changes the formula altogether. The 2 has to go in front. Because Na2F can't exist. Fluorine can only do a -1 charge. So octet rule tells me I can't just throw a 2 in front of the sodium, 2 behind the sodium. Because now I'm changing that. I'm changing that compound, and depending on what I do, it may not even exist. So on my sheet, 2, 2. Oh,
Oh, wait.
remember, I need 2 sodium chlorine molecules plus 1 fluorine gas molecule will react to form 2 sodium fluoride molecules plus chlorine gas. I don't change my molecule. I just add that I need more molecules for this to be balanced. That's all I'm aiming for. The coefficient tells me I need 2 sodium chloride molecules to react with 1 molecule of fluorine gas to form 2 molecules, guys, 2 molecules of sodium fluoride plus 1 molecule of chlorine gas. That's why I don't put the coefficient 2, go Na2. That formula is going to stay the same. I just need 2 of those molecules and 2 sodium chloride molecules, 1 fluorine gas molecule, 1 chlorine gas molecule. The formula doesn't change. I'm just adding a coefficient, a term you picked up in Algebra 1. All right, so this is where we're going to hit the pause button for today. What we'll do